Okay, welcome to the deep dive. We've got some really interesting material to get into today. It's an article laying out the details on Anthropic's newest AI model releases.
Yeah, some exciting stuff coming out of Anthropic.
Absolutely. So our mission for this deep dive really is to cut through the noise a bit and, unpack the key details about these new models. We want to understand their capabilities, see how they stack up performance-wise, and really zero in on what makes them stand out, especially when we look at things like coding and using tools autonomously, what people often call agentic behavior. We're sticking just to the info you shared.
That's right. So main news is about two specific models, Claude 4 Sonnet 4 and Claude 4 Opus 4. You can think of these as Anthropic's latest medium and largest size models in their family of general-purpose LLMs.
Okay.
And alongside that, they also announced the general availability of Claude Code. This was in research preview before, but now it's out there with an SDK. It's specifically designed as a coding agent.
Right, a dedicated coding agent. So, okay, what can these new models actually do? Based on the details here, the inputs seem pretty flexible. Text, images, even PDF files are supported. And they can handle a huge amount of input, right? Up to 200,000 tokens.
Yeah, that's a massive context window. And on the output side, Sonnet 4 can generate up to 64,000 tokens, which is quite substantial. Opus 4, the larger one, outputs up to 32,000 tokens.
Okay. Now, one feature that jumps out immediately is this parallel tool used for both models. What exactly does that mean? Like, they can do multiple things at once with tools.
Essentially, yeah. They aren't limited to using just one tool or performing one action sequentially. They can, for example, use a computer and potentially execute multiple actions or call different tools sort of concurrently. That's a pretty big step up for complex workflows.
Definitely sounds like it.
And another neat thing is this optional reasoning mode. You can actually choose to see the reasoning tokens the model generates while it's working. It's like watching its thought process.
Oh, interesting.
Yeah, and if that thought process gets really, really long, the source mentions a smaller separate model kicks in to summarize the reasoning, just to keep it clear. Oh, and they're multilingual too, supporting 15 languages right off the bat.
15. Wow. Okay. But here's something with Opus 4 that sounds like it's really pushing a frontier, according to the source material. It talks about creating and manipulating local files to store information, like using files as memory.
Exactly. This is a really crucial point, I think. It moves beyond just, what fits inside the prompt or the context window.
Right.
The example they gave is fascinating. So they tasked it with maintaining a knowledge base while playing a Pokemon video game. And Opus 4 apparently created a file, referenced it, and even generated specific state-aware advice.
Like what kind of advice?
Stuff like, if stuck, try opposite approach, or change Y coordinate when horizontal movement fails. That ability to recall info, add to it outside the immediate conversation using actual file, that's potentially huge for long-running complex tasks.
Yeah, I can see that. It's like giving it a notebook it can actually write in and read from later.
Precisely.
So, okay, those features sound impressive on paper, but how do they actually perform? How do they stack up in tests? The numbers shared in the material seem, well, pretty concrete. They're ranking right near the top overall.
That's what it looks like. They
Oh,
tied Google Gemini 2.5 Pro in the LMS WebDev Arena rankings. And importantly for our focus here, Anthropic's own tests show them achieving, quote, state-of-the-art performance on coding and agentic computer use benchmarks.
state of the art. Okay, let's dig into those benchmarks. You mentioned specifics.
Yes. Let's look at the SWE-bench verified test first. This one's about fixing real software bugs from GitHub issues. On this, Claude Opus 4 succeeded 72.5% of the time. And interestingly, Claude Sonnet 4 actually did slightly better here at 72.7%.
Huh, okay. Slightly better for Sonnet. How does that compare?
Well, the material specifically calls out OpenAI o3 as the next best mentioned model, which scored 70.3%. So, a couple of percentage points ahead. That might not sound like a ton, but in these kinds of complex tasks, it can be quite meaningful.
Absolutely. A clear lead there on fixing real code problems. What about the other benchmark? Terminal-bench.
Right, Terminal-bench. This tests how well the models can perform tasks on a computer terminal using an agentic setup. Here, Opus 4 took the lead with a 39.2% success rate. Sonnet 4 got 33.5%.
And the comparison there.
The closest competitor mentioned for this specific benchmark was OpenAI GPT 4.1, which the source says succeeded 30.3% of the time. So again, a noticeable gap, especially for Opus.
Okay.
And there's another layer to this. The material highlighted that when they used the specialized Claude Code agent framework with these models on Terminal-bench, the scores went up again. Opus 4 jumped to 43.2% success, and Sonnet 4 went to 35.5%.
Gotcha. So that framework really helps unlock their potential for these agentic computer-based tasks.
Okay, let's step back for a second. Why do these specific things, the parallel tool use, this file-based memory, the strong performance on coding and agent benchmarks, why does this all matter in the bigger picture?
Well, what these results and features seem to suggest is that we're seeing LLMs extend further into handling more complex, multi-step, and sort of stateful tasks. The ability to use external files as memory, like we talked about with that Pokemon example, that fundamentally changes the kind of problem an AI agent can potentially tackle. It's not just responding to one prompt anymore. It could maintain knowledge over time, track progress, update information, and handle tasks that need that kind of persistence.
And those user examples mentioned in the source really seem to back that up, showing the practical power, right? Building a Tetris clone in one shot. That sounds pretty complex.
Exactly. It implies a level of planning and coherent execution over multiple steps. Or the other example, that 7-hour stint refactoring Rakuten's open source code base.
7 hours. Yeah, that's not a trivial task. It requires sustained focus, understanding complex code, managing a big scope. These are the sorts of problems that really push beyond just simple Q&A or text generation.
Right. It's moving towards more capable AI assistants or collaborators, maybe.
That seems to be the direction. The combination of, the context, the tools, the external memory, and the benchmark performance. It all points towards a significant jump in potential for AI agents in areas like software development, data analysis, or really any task needing complex interactions and maintaining state over time.
Makes sense. Okay, just quickly touching on the practical side from the material availability and cost.
Sure. They're available through Anthropic's own API and also on Amazon Bedrock and Google Cloud Vertex AI. Pricing listed is per million tokens. For Sonnet 4, it's $3 for input, $15 for output. For Opus 4, it's $15 input and $75 output.
Okay, quite a bit more for Opus, as you'd expect. And the article mentions specifics like parameter counts or training data aren't disclosed.
That's right. Typical for these kinds of releases, those details remain under wraps.
Got it. Now, there was one other interesting tidbit mentioned in the We're Thinking section of the source material you shared. It involved a prompting expert at Elder Plinius, something about a system prompt.
Ah, yes, that was interesting. It pointed to a text file published by this expert, which is purported to be Claude 4's system prompt.
Oh.
The observation made in the source was that this file seems to contain material not found in Anthropic's officially published prompts.
Okay.
And that it's quite revealing about how the model might be conditioned for things like tool use, agentic behavior, and structured reasoning.
Huh. So like a potential peek behind the curtain at the instructions guiding the AI?
Sort of, yeah. A glimpse into that sort of invisible scaffolding that helps shape how these models tackle complex tasks, especially ones involving tools and multiple steps.
Fascinating stuff. Okay, let's try and wrap this up. So this deep dive into the info on Anthropic's new Claude 4 models, Sonnet 4 and Opus 4, really seems to highlight their push towards more capable AI agents. We saw how features like, the huge context windows, the parallel tool use, and especially that ability to use external files like memory.
Right, the persistent memory aspect.
We're underpinning some serious performance gains, particularly in coding and these complex agentic tasks. The benchmarks like SWE-bench and Terminal-bench show clear leads over mentioned competitors, and those user examples, the one-shot Tetris, the 7-hour refactor, they really paint a picture of AI tackling problems that felt maybe out of reach before.
Absolutely. And building on that thought, this ability to tackle complex multi-step problems, leveraging external memory, maintaining focus, all the things these models seem to be improving on.
Yep.
Here's something for you, the listener, to think about. If AI agents can truly remember context across sessions, manage evolving information using external files, and stay focused for really long durations, maybe days or even weeks, what entirely new kinds of long-haul, information-heavy tasks might suddenly become feasible? What does that capability change about how we might collaborate with AI on really large, complex projects down the line?